Hi, my name is Scott Bretthauer, and I'm with the University of Illinois Extension. I'm part of the Department of Agricultural and Biological Engineering. I'm here to talk about the new sprayer calibration calculator. It's an app that was developed for tablets and smartphones, both for the Apple and Android operating systems. The sprayer calibration calculator was set up to do various functions related to calibrating and setting up a sprayer. And it's got four main functions at the beginning: calibration, PSI for GPM, nozzle speed, and convert value. And of course, the main one is calibration. If we select it, it goes to this menu where it tells us we can calibrate for an aircraft, a ground rig, turf boom, or a boomless sprayer. So you would choose whatever type of sprayer it is you're trying to set up. We're going to start out, we're going to have a ground rig, for example. It goes to this menu now where I've got these various variables that I'm going to enter in the information. What I'm going to start with is speed. So I'm going to say that my speed for this application will be 12 miles per hour. The next variable I can enter is nozzle spacing, and this will be the distance between my nozzles in inches, or if I'm making a band application, it's the width of my band in inches. So I'm going to say that I'm doing a broadcast application with 20 inches between my nozzles. So I scroll down, select 20. So it enters a 20 there. The next one that I'll enter is my target gallons per acre, GPA. So for this, I'm going to say I'm going to be targeting 10 gallons per acre. And when you're using this app, if you look at any of these and you have a question about, I'm not sure what that variable means, if you just tap on that variable, it will actually bring up a definition of what that variable is. So when you're using the app, if there's any questions about what a variable means, you're not sure what the acronym stands for, you can just select on it. It'll give you an explanation to help clear that up. So I've set up for 12 miles per hour, 20 inches between my nozzles, and a targeted spray application rate of 10 gallons per acre. And you can see that the app has calculated the required flow rate I need in gallons per minute. Again, if I click on that, it'll say GPM is the gallons per minute. That's the nozzle flow rate required for this application. Close that out. So I know that in order to apply 10 gallons per acre with nozzles 20 inches apart at a speed of 12 miles per hour, I need a flow rate of 0.40 gallons per minute. Now I have the option to save this setup. So if I know that this is a typical setup I'm going to be using for spraying, I can save it so I don't have to come back to it again. And it defaults as saying this is a ground rig, and then it gives me the flow rate, 0.40, and it saves, and then it loads the date. So I can just save it as the default, or I can type in there and change this to my own name. I'm just going to go ahead and go with the default and save that, and it saved those results. So the next step in the calibration process then would be to try to find a nozzle type, orifice size, and pressure that provides this flow rate of 0.40 gallons per minute. We go to the nozzle catalog pages then to find the appropriate nozzle type, orifice size, and pressure to make our application. Remember, we're looking for a flow rate of 0.40 gallons per minute. So when we look at the page here, I picked the page for the turbo T-jet nozzle, there's a lot of information contained on that page. The first thing you'll notice is on the far left-hand side, we have our different orifices. The TT tells me that this is for a turbo T-jet nozzle. The 110 is for a spray angle of 110 degrees. So the angle of the spray pattern when this nozzle is operated at 40 psi would be 110 degrees. And then the flow rate is 0.1 gallons per minute. So those last two numbers tell me the flow rate. My next column gives me the pressure range for the nozzle. So this nozzle can be operated between a minimum pressure of 15 and a maximum pressure of 90 psi. The next column is the droplet size created for each one of these orifice size and pressure combinations. The next two columns are the flow rates. The first column is the flow rate in gallons per minute, and the next one is the flow rate in fluid ounces per minute. So for my application, we needed a flow rate of 0.4 gallons per minute. So if I scroll down here, I can see that if I select the TT11004 nozzle and operate it at 40 psi, I have that exact flow rate of 0.40 gallons per minute that I need for this application. So what we can do, we'll go back to calibration. This time we'll do a turf sprayer. So basically the same setup as we saw before. The biggest difference between a turf application and a standard ground rig application is that instead of measuring the spray application rate in gallons per acre, it's typically measured in gallons per 1,000 square feet. And again, if you have any questions about any of those variables, you just touch on it and it will bring up a definition for that variable. So we're going to go through and we're going to do the same thing. For this application, we're going to enter that we're going to be traveling at 3 miles per hour. Our nozzle spacing will again be 20 inches between the nozzles. And this time our target gallons per 1,000 square feet application rate will be 2 gallons. So we want to apply 2 gallons of spray per 1,000 square feet. You see it again, the app will calculate the required flow rate in gallons per minute at 0.88 gallons per minute. So similar to the last time, now we know the flow rate that we need out of our nozzle in order to make this application. Just like before, it allows me to save that. So this is Turf Boom 0.88 and again the date. So I would save that application. So another option for calibration, we select calibration, aircraft. So similar to the other types, we're going to be entering in variables. There's just more variables with this application. The first one we'll enter is the speed. In this case, it allows me to just type in the speed. So I'm going to enter in 140 miles per hour. For aerial applications, we measure our effective sprayed width as a swath width in feet, not the distance between nozzles and inches. So it says swath, and again, if I click on it, it'll tell me that swath width covered by the nozzles in feet. So we enter that, and it's going to be 66. I'm going to take a 66-foot swath width with this aircraft. My target gallons per acre for this application will be 3 gallons per acre, and I have a total of 36 nozzles. Now, this part of the app will calculate 2 different things. First of all, it calculates the entire gallon per minute flow rate for the whole boom. So I know that what I need out of the entire boom. So if I added up all the nozzles on the boom, I need a total of 56 gallons per minute to come out of all the nozzles on the boom. Then it also calculates the boom gallon per minute per nozzle. So I've told it needs to have, it just calculated it needs a flow rate out of the boom of 56 gallons per minute. And I've got a total of 36 nozzles, so it's going to split that flow rate up between those number of nozzles. So if I need a flow rate of 56 gallons per minute, and I have a total of 36 nozzles, each nozzle needs to produce 1.56 gallons per minute. And you can see here, if I change this, let's say I'm going to go to 40 nozzles, the boom gallon per minute has not changed because at 140 miles an hour, a 66-foot swath width, and a target application rate of 3 gallons per acre, no matter how many nozzles are on the boom needs to output 56 gallons per minute. But now with 40 nozzles on there, each nozzle only has to produce 1.4 gallons per minute. So we're going to go back to 36 nozzles, and we're back to our 1.56 gallons per minute. Now there's a second page of the aircraft calibration. The first thing we're going to do though is save this one. So it says it's aircraft, 56 gallons, that's the 56 gallon per minute flow rate for the boom, and again the date. So I'll save that. Successfully saved, then I'm going to scroll to the second page, and this is where I can fine-tune my application and get the exact number of nozzles, the orifice size, and the pressure that I want to make this application. So you can see it's loaded from that first page the needed boom gallons per minute, so 56 gallons per minute. Now this section has the option, sometimes for aerial applications we might use 2 different orifice sizes mixed along that boom to generate the required boom gallon per minute flow rate. So it loads up as just having one nozzle, but if I wanted to add a second nozzle, I would just hit the plus sign, and now I have 2 different orifice sizes that I can enter in here. So for this application, I'm only going to use one orifice size. So the first thing I'll come down and do is load my flow at 40 psi. So I have a nozzle size in mind that I want to use, and I'm going to look at the flow rate table for the nozzle manufacturer from their catalog. And in this case, I'm thinking about using a 40-15 nozzle. So it's a 4-degree flat fan pattern. And the 15 tells me it puts out 1.5 gallons per minute at 40 psi. So therefore, the flow for this nozzle at 40 psi is 1.5 gallons per minute. Again, if I'm confused as to what this means, I just click on it, and flow at 40 psi is the flow rate in gallons per minute produced by the nozzle size when operated at 40 psi. And this is the information you would get from the nozzle manufacturer. So I've entered in that the flow for this nozzle that I'm interested in using is 1.5 gallons per minute. I had 36 nozzles, and this section allows me to change this, to fine-tune this. So even though I'd entered in 36 nozzles on the first page, it doesn't automatically bring that over, because a lot of times what we're doing here is fine-tuning the exact number of nozzles and the pressure and the size to get that exact flow rate for the whole boom. So I've entered in the 1.5 gallon per minute, and then I have a total of 36 nozzles. And you can see here that my nozzle gallon per minute, the total for all the nozzles, and the boom total are all going to be calculated. They all have green squares indicating the app will calculate these, but they're all still blank. The last thing I have to enter in here is my pressure. So I'm going to just start with a standard pressure of 40 psi. So if I enter in 40 psi, it calculates that this size nozzle at 40 psi will produce 1.5 gallons per minute. Then for all the nozzles on the boom of that size, it will do 54 gallons per minute, and of course the boom total then is going to be the same. If you're only using one nozzle, the total for nozzles and the boom total will be identical. The difference occurs if you're going to load a separate orifice size on there. So I look, and with this nozzle operated at 40 psi and 36 of them, I get a total flow from my boom of 54 gallons per minute. What I need, loaded from the first page, was 56 gallons per minute. So what I'm going to do is I'm going to have to increase the pressure. So I'm going to try a pressure of 45 psi. It recalculates. Now this nozzle size at 45 psi will produce 1.59 gallons per minute, which gives me a boom total of 57.27 gallons per minute, a little bit more than what I need. So I'm going to back the pressure down to about 44 psi and pretty much right on. If I operate 36 nozzles that have a nominal flow rate of 1.5 gallon per minute at 40 psi and operate them at 44 psi on my boom, each nozzle produces 1.57 gallons per minute for a total of 56.6 gallons per minute for all those nozzles, and then the boom total would be the same, 56.6 gallons per minute. You'll never get it exactly right. You're basically trying to get the whole number to match up. So 56 gallons per minute total for this setup, and I needed a target of 56 gallons per minute, so that means this setup will work for my application. And again, I can further save this so that I don't have to come back. If I'm going to make another application like this, I can just load this back up here and it'll reload all those pages for me. The last type of application that I can calibrate for with the app is a boomless application. This would be for like rights-of-way applications where I'm just using a single off-center nozzle. So for this example, we'll pick 6 miles per hour, be covering a swath width of 15 feet, have a target GPA of 20 gallons per acre, and it calculates that I need a flow rate of 3.64 gallons per minute out of the nozzle. So very similar to before. The biggest difference with this compared to the ground rig or turf is similar to the ground rig, we're measuring our spray application rate in gallons per acre. The difference is, instead of distance between nozzles on the boom, our swath is the swath width covered by the nozzle in feet. So we're covering 15 feet with this nozzle. And so at speed of 6 miles per hour, covering 15 feet with a nozzle and applying at 20 gallons per acre, we need a flow rate of 3.64 gallons per minute. And again, I can save that so that I can look at it later should I need to reference that application setup again.